Hey everyone, today we'll be diving into three interesting calculus questions. First, we'll compare the derivative of two functions. Secondly, we'll predict a useful rule for differentiating reciprocals. And finally, we'll test whether a common derivative rule is true or false. Let's get started. So we're going to be comparing the derivatives of these two functions. Y is equal to 1 divided by x squared plus 1, and y is equal to x divided by x squared plus 1. These are some similarities and some differences. Both of these functions are quotients with a denominator x squared plus 1, but the numerators are different. Let's differentiate them using the quotient rule. So the quotient rule states that h prime of x is equal to f prime of x g of x minus f of x g prime of x divided by g of x squared. If we apply this rule to y is equal to 1 divided by x squared plus 1, we'll get an answer of minus 2x divided by x squared plus 1 squared. So when f of x is equal to 1, f prime of x is equal to 0 because the derivative of any constant is equal to 0. If we apply the same rule to the second function, y is equal to x divided by x squared plus 1, we'll get an answer of 1 minus x squared divided by x squared plus 1 squared. While both of these functions have the same denominator squared in their derivatives, the numerators differ. The first function's derivative is negative, while the second has a mix of positive and negative terms. This is because in y1 the numerators are constant, while in y2 the numerators are variable. That contributes to the derivative. Okay, this is the first question. Let's move on to the second. So we're predicting a rule for differentiating y is equal to 1 divided by g of x prime, where g of x cannot be equal to 0. Instead of using the full quotient rule, a useful shortcut for derivatives of a reciprocal function is 1 divided by g of x prime is equal to negative g prime x divided by g of x squared. This can be derived from the quotient rule, but it's a useful rule on its own. For example, let's use the previous function. Y is equal to 1 divided by x squared plus 1. Using this rule, g of x is equal to x squared plus 1. G prime of x is equal to 2x. So y prime would be equal to negative 2x divided by x squared plus 1 squared, which is the same answer that we got previously. Finally, let's evaluate this statement. The statement is, if q of x is equal to f of x divided by g of x, then q prime of x is equal to f prime of x divided by g prime of x. Let's see if this rule is true or false. The actual quotient rule states that q prime of x is equal to f prime of x g of x minus f of x g prime of x divided by g of x squared. Let's test this with an example. Let f of x equal to x squared and g of x is equal to x plus 1. So q of x is equal to x squared divided by x plus 1. So let's use both formulas. First, we need to find the derivatives. F prime of x is equal to 2x and g prime of x is equal to 1. Let's use the first formula. Q prime of x is equal to f prime of x divided by g prime of x. Following this formula, we get 2x. Now, let's use the quotient rule. Using the quotient rule, we get q prime of x is equal to 2x multiplied by x plus 1 minus x squared times 1 divided by x plus 1 squared. Our answer for this is x squared plus 2x divided by x plus 1 squared. Since 2x is not equal to x squared plus 2x divided by x plus 1 squared, this proves that the given statement is false. The correct way to differentiate quotients is to use the quotient rule. To wrap up, we've learned that derivatives of fractions often require the quotient rule, but we can sometimes use shortcuts. We also saw that dividing derivatives directly doesn't work for quotients. Thanks for watching.